According to Dr. Nick Turan, a nuclear reactor is a system that contains and controls sustained nuclear chain reactions. Reactors are used for generating electricity, moving aircraft carriers, and submarines, producing medical isotopes for imaging and cancer treatment, and for conducting research. Fuel, made up of heavy atoms that split when they absorb nutrients, is placed into the reactor vessel, basically a large tank, along with a small neutron source. The neutrons start a chain reaction where each atom that splits releases more neutrons that cause other atoms to split. Each time an atom splits, it releases large amounts of energy in the form of heat. The heat is carried out of the reactor by coolant, which is most commonly just plain water. The coolant heats up and goes off to a turbine to spin a generator or drive shaft. Here are the main components of nuclear reactor. First is the core. The core of the reactor contains all of the nuclear fuel and generates all of the heat. It contains low and rich uranium, control systems, and structural materials. The core can contain hundreds of thousands of individual fuel pins. The second one is coolant. Is the material that passes through the core, transferring the heat from the fuel to a turbine. It could be water, heavy water, liquid sodium, helium, or something else. In the US fleet of power reactors, water is the standard. In here is the turbine. Transfers the heat from the coolant to electricity just like in a fossil fuel plant. And the last is the containment. The containment is the structure that separates the reactor from the environment. These are usually dome-shaped, made of high-density, steel-reinforced concrete. Chernobyl did not have a containment to speak of. Types of reactors. There are many different kinds of nuclear fuel forms. Moderators and cooling materials can be used in a nuclear reactor. As a result, there are thousands of different possible nuclear reactor designs. Here, we discuss a few of the designs that have been built before, but don't limit your imagination. Over a million other reactor designs are possible. Number 1 is pressurized water reactor, the most common type of reactor. The PWR uses regular old water as a coolant. The primary cooling water is kept at very high pressure so it does not boil. It goes through a heat exchanger, transferring heat to a secondary coolant loop, which then spins the turbine. These use oxide fuel pellets stacked in zirconium tubes. They could possibly burn thorium or plutonium fuel as well. The second one is boiling water reactor. The second most common. The BWR is similar to the PWR in many ways. However, they only have one coolant loop. The hot nuclear fuel boils water as it goes out the top of the reactor, where the steam heads over to the turbine to spin it. The third one is Canada Deuterium Uranium Reactors, in short CANDU. CANDUs are Canadian design found in Canada and around the world. They contain heavy water where the hydrogen in H2O has an extra neutron, making it deuterium instead of hydrogen. Deuterium absorbs many fewer nutrients than hydrogen, and CANDUs can operate using only natural uranium instead of enriched. The fourth one is sodium cooled fast reactor. These reactors are cooled by liquid sodium metal. Sodium is heavier than hydrogen. a fact that leads to the neutrons moving around at higher speeds, hence fast. This can use metal or oxide fuel and burn a wide variety of fuels. The fifth one is molten salt reactor. There is now a full page discussing MSRs in detail. Molten salt reactors, or MSRs, are the internet's favorite reactor. They are unique so far in that they use fluid fuel. The sixth one is high temperature gas cooled reactor. HTGRs use little pellets of fuel back into either hexagonal compacts or into larger pebbles. In the prismatic and pebble bed designs, gas such as helium or carbon dioxide is passed through the reactor rapidly to cool it. Due to their low power density, these reactors are seen as promising for using nuclear energy outside of electricity, in transportation, in industry, and in residential regimes. They are not particularly good at just producing electricity. The animation above, reproduced from the NRC, shows a nuclear reactor heating up water and boiling a generator to produce electricity. It captures the essence of the system well. The water coming into the condenser and then going right back out is water from a river, lake, or ocean. It goes out to cooling towers. As you can see, this water does not go near the radioactivity which is in the reactor vessel.